To another class with me. My name is Ming. Today we're going to look at this particular learning targets. That is how to find the volume of a solid from revolving about the x-axis, but the region is bounded one and is obtained from two functions. Okay, so we will start with this. So find the volume of this shaded region rotated about the x-axis by 2 pi radian. That means making 360-degree turn. The first thing that we need to do is to find out these two intersection. So this look like 0, this look like, what is that? So to do that, I'm going to suggest that you use your graph, right? So graph and then use the function, and then the first one is E. So E is you select it from this button and then put in E, and then to the power of x over 2, enter. And the next one, go back to the menu, graph entry, and then function again. So this is going to be x plus 1. And now I find the two intersection. And then this is by analyzing the graph, intersect. So start from here and then go across and until you find the first intersection. So it's 0, 1. And the second intersection will do the same thing again. Analyze graph, intersect again, start from the left of the intersection over here, lower bound, and go across. And then you can see that the answer is here. And I want to save this A because it's such a big number. So I'm going to save this A by doing, by clicking on it and then store the value. And then now I just put in bars here is A. So, so it will solve for A, and you can see that now it is highlighted. So it's a link to A. You can also do Control var to store the value. Now, we will look at the, so this is going to be 0. I know that is 0 here, and here is 2 point, what was the number again? 51286, for example, 51286 dot 251286, right? And to figure out the volume, think of it this way. First, I rotate the linear line y equal to x plus 1 around the x-axis to form something like a truncated cone. And then after that, I rotate the exponential function e to the power x over 2 around the x-axis again, now to obtain this like a trumpet-like thing, and we will hollow this volume from the truncated cone to get something like a tube, right? And what is the volume of this particular tube? So now we can put in the information. So the information is from 0 to 2.51286 dot. Here's the same 2.51286, that is dot from 0 to there. And the first part is the linear line, everything square, minus the exponential, everything square. So if this is paper 1, I have to do the integration by hand. So this is going to be x plus 1 everything cubed divided by 3, and this is going from 0 to 2 to 2.51286 dot minus this, and this is e to the power of x over 2 times 2. So this is going to be e to the power of x. The integration of e to the power of x is just going to be e to the power of x itself, because the derivative of e to the power of x is e to the power of x. So that's from 0 to 2.51286 dot. And now I just use your GDC to find an answer here. To find the answer, right, I will need to go back to the Scratchpad. So you can put in pi here first, and then a big bracket, and then you can put another bracket for the linear function, which is x plus 1, but I need to have a plus 1, and then everything cube, and then after that divide by 3, and then minus e to the power of x. So e is that use this button again, the one below e. So e and then raised to the power of a. In this case, a is right, and then I have to minus. Right, so this is where 1 cube, right? 1 cube is just 1 divided by 3, and then minus become plus, e to the power of, let me delete that, plus e over here, e to the power of 0, which is 1, right? And then enter. So I'll get 8.72193. This is what I get, 8.72193. So 8.72 to 3SF. I could have done the same thing using the a little bit differently. If this is paper 2, I can also write this thing out where I will put pi out here. A is from here. F2 is the function square. That is, I could have done it this way as well. That is, using the menu, go to calculus, and then put in numerical integral. And put in the pi outside. So use this, pi outside, and then put in here 0 at the lower bound. Upper bound is my A. And then inside, I need to put big bracket. And then another bracket, minus another bracket. So this is the function of, you do vars, and then select that my linear function is f2, and then put in x, and then square. Minus vars again for my exponential function, which is f1, x, and then square. And then put here the x, and then I press the answer. So you can see that they're exactly the same thing, obviously, right? So you can also do it this way. And over here, I have a question for you. This is one with rotating around 2x, rotating by 2 pi radian around the x-axis. And the next question is actually rotating around y equal to 0.6, also 360 degree or 2 pi radian. I leave this as a work for you to do. You may want to discuss this with your friend or your teacher, and later check another video of mine to see the solution. Bye bye.